Oops, part D. How many arrangements are there with 2 blueberries if we count arrangements by rotation as being the same?
Well, if we ignore, we'll just have to divide by 2 at the end for the flipping stuff.
Okay.
So if we ignore that now, but we can't always rotate both blueberries so that they're in the upper left-hand corner.
No, that's a very good observation. We can't do the same thing we did before with 1 blueberry because we can't put them both in the upper corner.
Well, but we do have some arrangements that you can rotate. We have 3 other arrangements.
All right, for
aside
this
from
one,
that one.
we have 3 other arrangements.
So you might have to divide by 4.
You might have to divide by 4. Do all of the arrangements of the blueberries have 4 pairs?
Well, if you put it like that, there would be still 4 pairs.
Okay.
So
It looks like all of them have 4 pairs since you can just rotate it. But,
is there one?
I think there
You've
might,
only checked 2, right?
I think there might be another. I think there might be one.
See if you can find one that takes advantage of some symmetry in the square.
I think. What if you
That
place
only-
this one at the upper corner?
Ah, what happens then?
Well,
Then if you rotate the plate, it's not the same.
and then that one's back to where you started.
Ah, so how many pairs does this one have?
It only has 2.
Oh boy. So
So
some of the pairs have 4,
And some of the pairs have 2.
and
how
some of
many?
the pairs have 2. Huh. So first we thought we could divide 120 by 4.
But we can't.
And we would get what if we divided 120 by 4?
You'd get 30.
You'd get 30.
But that doesn't work.
But that doesn't work because,
Some of them have 2. But
right,
how are we going to divide that?
well, we're going to have to separate it out.
Yeah.
Which are the ones that only have 2
Well,
friends?
it's the one where they're directly opposite each other. Wait, no, this one has 4.
That one has 4, but
Well,
what one has 2? Where
I think the ones on the corners.
the ones on the corners have 2, okay. But your idea of them being directly opposite is important.
But what
These-
if they're almost directly opposite?
Or what they
What if-
Blueberries getting mushy.
Okay.
What if they're like this?
All right, now, that's interesting. What happens now?
Well, then you have this arrangement, and then this is the starting arrangement.
That's the starting arrangement, okay.
So,
those they might only have 2 also.
All right, so those only have 2. Can you find some other pairs that only have 2? So you found the opposite corners, the opposite edges. These are opposite by rotation. This
Yeah.
is where that one rotates, okay?
so we could have this.
Well, then if we have these 2 corners, then we also have to have these 2 corners.
Yeah.
We could do that.
And then we just have to have the
Ah, look at that on the inside.
inside. They only have 2.
They only have
And that
2.
makes sense because the outside corners only had 2. Now the inside only have 2.
Right. Okay. Is there anything else that's only going to have 2?
I don't think so because the interior opposite pairs are these.
Okay. So that's interesting. So we have, let's count these ones out of our, remember how many there were where we didn't worry about rotation?
There was 120.
Okay, so there's going to be 1, 2, 3.
Yeah, and then 4. That one counts as another one.
4,
5,
5, 6, 7,
7,
8, 9, 10,
10,
11, 12. 12 on the
12.
outside. How many on the inside?
And then 1, 2 on the inside, so that's 14.
There's 14
That do matter about that
that
matter.
pair up in groups of 2.
So maybe we could subtract. We subtracted 14 from 120 and then just divided that by 2.
Okay.
But then divided the rest by 4.
Ah, that'd be interesting. But do you see a problem?
But 106 isn't divisible by 4.
Ooh, 106 isn't divisible by 4.
So how are we gonna...
Haha. I wonder what that means.
Maybe we should ignore, if we ignore the flipping pattern,
Which flipping pattern?
the one where if we count this and that as being the same,
Okay.
if we ignore that, then we get 212 as the number left over. Actually, it's not, it wouldn't be 212 since everything would be doubled.
Well, let's see. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
And then we have
and then
that.
13,
Here.
14.
So there still is, it still would be 14. But what would you subtract it from? So you have 240 minus 14. Well, that doesn't give you, that still isn't divisible by 4.
It's not?
Because wait, 240 minus 14. That's 226.
It's not divisible by 4.
No. It's divisible by
Because-
2, but not by 4.
Because the one you'd get 113.
So what can we do? It seemed to work, but
Yeah, I think we forgot to count something. We got 12 around the edge, and then 13. And we got 13, 14, 15, 16. There's 4 in the middle here, right? Because we counted all those.
Yeah, and what about if they're right next to each other, they have 4?
Yeah.
yeah, so so if we're not counting the flipping, then that works. Then you can
I don't know what you mean when you say we're not counting the flipping.
well, if we count this as being different from this.
Ah, very good. We have double counted here. We counted 16 cases as being different from each other. But there's really only 8 cases, right? Because of the flips.
Yep.
Okay, and then we have to divide that by 2.
So that would be 4.
So there's only 4 cases here. Okay,
4.
so there's 1, the opposite corners.
And then
These opposite edges, 2, 3,
3.
right? Because
No.
these are
Yeah.
different. These don't rotate to each other.
Yep. And then the ones on the inside.
And one on the inside is 4. There we go, we got it. And we had to subtract 16 from 120, right?
Yeah.
And then
And that leaves us with 104.
104.
Which is divisible by 4.
What is it? 4 times what?
That's 4 times 26.
4 times
Yeah.
26. Okay.
So then we have to divide the rest by 4.
Divide the rest by 4.
So we get 26.
26 plus how many did we have before?
Plus we had the 14 or the 16 that we had to divide by 2.
Yeah.
And
So
then
that's 8.
Okay.
So 26 plus 8.
so 34.
Okay, we're almost there. We're almost there. Let's go to E.
All right.